Hey guys, this is Dr. Cody Rall with Techforpsych. In the previous video, we took a look at the Muse headset from Interaxon. We paired it with our phones through Bluetooth so that we can do a neurofeedback meditation session. In this video, we're going to get a little bit more technical. We're going to pair the Muse headset with our computer so that we can use the Muse software development kit to record the brainwaves and then use MATLAB to look at the brainwaves and do cool stuff with it, like map it to 2D and 3D heads.
All right, so the first thing I want you to do is go to the Muse developers website. You can just type in Muse developers on Google and go to the developer portal. And what you'll notice when you fall into the Muse developers website, you got the developer software kit and the research tools. And since I'm using a Mac, I'm going to download the Mac version. What you'll notice on the research tools page is there's a lot of instructions there that you can scroll through. They got a good introduction where it tells you how to install the research tools, how to pair your Muse with your computer through Bluetooth, how to run the Muse I/O, which basically communicates with the Muse device with your computer through Bluetooth. Scrolling down, you can see the Muse Lab, which is the graphical user interface that you can record Muse recordings, the EEG recordings, for use at a later time as well. Now, once you download the Muse software development kit and run the installer, you should see a folder somewhat like this. This is how it looks on my Mac. And I want you to notice that the Muse I/O and the Muse Lab are there. I want you to take a look at Muse I/O, and I want you actually to go back to the software development portal and take a look at the instructions for Muse I/O, because this is how we're going to link our Muse headset with the computer. It's a little bit more involved than just getting your Muse headset to link up with your iPhone, for example. A little bit more technical, but once you do it once or twice, it's really not that big of a deal. The first step is to get out your Muse headset and press down the power button for about 5 seconds. Now what's going to happen is the back light is going to start flashing on and off, and that means it's in pairing mode. At that point, you should be able to go to your Bluetooth connection on your computer and see the Muse headset show up on the list of devices that you're capable of pairing with. When you click on the Muse headset, it will go into pairing mode. And it might not necessarily connect at first, but what's happening is the computer and the Muse headset are communicating. At that point, what you need to do is open up the Muse I/O and enter the commands exactly as you see it on this window. Basically, it's the -muse-io -- and then whatever Muse name is specific to your particular headset. It's going to be different for different people. At that point, the Muse I/O should start communicating with the Muse headset. The data should start streaming in, and you're officially connected between your computer and your Muse headset. Now that we're connected between our computer and our Muse headset, we can open up Muse Lab. Now, Muse Lab is a graphical user interface for visualizing and recording the data that is streaming in from the Muse headset device. Now, when you open up Muse Lab here, what you'll see is you have a data port. The OSC is a data port. And I've actually got the headset on my head, and you can see that it's not connected via the horseshoe. Now, if you look at the instruction of the website, you enter in 5000, which opens the specific port that the Muse headset connects to within your computer, and then you get all the data streaming into Muse Lab. The next thing that we're going to do is, if you take a look at that scroll bar, again, where I said it's OSC, you can change it to the visualizer function in order to actually see the data as brain waves. All right, now that you're in the visualizer section, you can click New and go to Scrolling Line Graph, and that will set up the parameters for actually looking at the brainwave data. Now, if you look under Signals, what it has is a bunch of different types of data that you can look at. A lot of it is actually basic stuff about the headset that you don't really need to be looking at. Because the scrolling line graph won't be able to make sense of it. But what I want you to do is pick different frequency bands to look at. I'm going to pick alpha, I'm going to go down to beta, and I'm picking relative just to have the data already been analyzed by the program and graph. We'll talk about that later when we look at raw data. But I'm picking delta there in the relative. I'm going to go down and pick a gamma. So I'm just scrolling down seeing what I want to choose, and the rest of it looks like raw data. There's theta down there, but I'm just gonna now I'm gonna go over to settings and click up the amplitude. And by clicking up the amplitude, you can actually see the variations. Before it was damped down too much to see the variations in the frequency bands, but now as you can see, you can actually see the different frequency bands that are happening as I've got the headset on my head right now. As you can see, the horseshoe up in the upper right is showing that it's connected. You'll also have the battery life there at 58%. Now I will say at this point that covers the basics of connecting your Muse headset to your computer and looking at the brainwave data on Muse Lab. What I'm going to get into now is more technical and takes more resources. And I don't think everybody needs to get this far, but if you're interested in doing scientific experiments with your brainwave data or getting into software development, I think that this route can be helpful. And my hope is by putting up this tutorial that people will see what I've done and sort of build on that. And I'm not claiming any expertise in this area. I do most of my work in clinical neuroscience. I'm really doing this on the side to learn more about the software development and the personal EEG device field. So if anybody has critiques or advice for me, please email me at hello@Techforpsych. All right, so let's jump into it. The first thing that I want to talk about is MATLAB. Now, if you're not familiar with MATLAB, it's this very powerful data analytic program that we're going to use to look at the Muse headset data. Now, if you're a part of an institution, I would look at if your library has access to MATLAB. I know that they have agreements with different institutions, and you might have access. But if you're working on this stuff from home like me, they now have this home version for $150, which is really awesome. So you can type into Google MATLAB Home Edition and go to the link. And there it's advertised right there, MATLAB for $150. And you can add plugins for $45 each. There are these additional toolboxes that you can add depending on what you're doing. I haven't had to buy any of those. I just bought the baseline product and have been quite happy with it. So you can just check that box and download the program. Now, if you've never used MATLAB before, I would recommend a textbook called MATLAB for Neuroscientists. You can just Google it and find it on Amazon. But it's this really fun textbook that takes you through the basics of looking at data in MATLAB, manipulating and mapping it so that you understand the basics of MATLAB better. And the cool thing about the textbook is that they link it to neuroscience experiments. And I think it's a great primer for what we're going to try to do here. Now, the reason why we're even getting MATLAB in the first place is so we can use a program called EEG Lab. EEG Lab is a free program. It's offered through the University of California, San Diego. And if you go to Google and just type in the name EEG Lab and search for that, you'll find their website. You can just go right to it. There's a good explanation of what EEG Lab actually is, some pretty pictures of brain maps that we'll try to do later in this tutorial. Got a video here of the different electrical activities happening within an experiment. Some more descriptions below about what electrical activity it's picking up from the brain and how it maps it onto different 3D and 2D maps. To download, just go to the options there, click download, enter in your name, your email address, click submit, and download the program. Now, if you look at the EEG Lab website, they actually have a ton of tutorial material. It would be a good idea to look at the tutorial material there. They have a whole wiki tutorial page, and you see all the different sections there. It would be a good idea to take a look at the basics before going much further. Basics like loading data into EEG Lab. And you can scroll down and see all the instructions they have for it. We'll go through some of it, but I think that you need to read through to get the basics. There's other things like mapping where the head leads are and visualizing the data in another scrolling graph within EEG Lab. Once you download the EEG Lab folder, I want you to unzip it and actually locate the files. And what you're going to do next is you need to find the MATLAB file. And what you need to do is put the EEG Lab files under MATLAB. As you can see, I've set up a folder called EEG Research, and I've actually put the EEG Lab files within it. Now, the reason why I did this is because when you're going to open MATLAB, you need to set paths. Because MATLAB is such a complicated programming system, you need to activate certain pathways so that when you enter commands in the command window, it knows what you're talking about. It needs to define different objects and keep data in line, and things get really complicated really quick. So you're going to go to the EEG Lab research folder, click add to path so that all the subfolders are activated, so that when you put in EEG Lab in the command window, it opens the EEG Lab graphical user interface through MATLAB. Now the cool thing about EEG Lab is they actually have sample data loaded in that you can use for practice basically. Now if you look in the EEG Lab folder and you go to the subfolder called sample data, you can see all the sample data files that are within there that we're going to use for an example. I'm showing you that so that you know that they're in there, and when you're in the graphical user interface, you can go to File, Import Data. Now don't use the first option, that uses MATLAB arrays, which we'll use later on. But if you go to Load Existing Data, you can find that sample data within the sample data file and click on the EEG Lab data set. If you click Open on that, you can see MATLAB crunching the numbers behind the graphical user interface window, and then all of a sudden it says continuous EEG data. So it's loaded in. You can take a look at the event data, and I'll talk about the actual experiment that was used to collect this data. It's kind of interesting, but if you click through, you can see the different data sets. You can click plot and channel data, so you can go to the scroll graph. And as you can see, this has 32 leads. Each one of these lines represents a different lead, a lot more than the 4 leads that we'll have come out of the Muse headset. So this is where you see people having those wires all over their head because they have sensors all over, and this is research grade data. Not that the Muse data is not accurate, but it's far less leads, as you'll see. Now that we've seen the data on a scrolling line graph, what we want to do is plot it on a 2D and 3D head. Now you can't go to plot right away. What we're going to have to do is go to edit and then go to channel locations. And basically what we're doing is telling the program where on the head that the data is coming from in terms of where the channels are at. Now if it brings up this window and you can see read locations down in the lower left, I want you to bring that up. And as you can see, I can go into my EEG research folder where the EEG Lab is and the sample data. If you recall, we're using the sample data. And you see this EEG Lab channel 32.locs. And when you open that, it loads it into this window. And again, what this is doing is telling the program where the data is coming from in terms of what channel number it is. If you bring up the plot 2D, you can see the different channel locations as they're mapped out on the head. Each one has its own unique name. And as you can see, this is the 32 channel sample data that we're using here. Then what you can do is go to plot, you can go to channel spectra and maps, and it has the frequencies to plot as scalp maps, and it has 6, 10, and 22 on here. You can change those frequencies on that window before you open it up, but it's pretty cool. You get the frequency bands here, and if you open up the 2D view, you can see where they're concentrated on the head. There's the tan there. You can see the different channels that are lighting up more than the others in terms of where the frequencies are coming from. One of the coolest things about this program is that you can map your data to a 3D head model. In order to do that, the program wants you to extract something called an epoch. Now, an epoch is a specific amount of time within the experimental paradigm where the different electrical activity is happening depending on what you've done to the subject in the experiment. Now, if you get the epochs right and you average them together, you can get something called an ERP, which is an evoked related potential, which has a lot of significance in neuroscience. We won't get into the nitty-gritty on that, but for now we'll just show you how to do it. Just go into Tools and then go to Extract Epochs. A number of windows will come up. You can just click OK through them. As you can see, MATLAB is working in the background extracting the data. And once you get through the baseline removal and the data info, you can go to Plot and then go down to ERP Map Series and go in 3D. Click OK. This is a spline file. Just click Manual Code Registration button there, and you get this 3D head map. What it wants you to do from here is go to Warp Montage. Now it's going to take the data that you already have and just warp it. You can just press OK on that window, press OK again on that window. And then what it wants you to do is click in latencies, and the EEG Lab instructions just say 0, 100, 500 is good enough. And what it does is at each time frame, the 0, 100, 500, it shows you the 3D map of the data. It's so cool. And you can click on each one, bring it up, and rotate it around. And just like the 2D map, you can see at which time frame the brainwaves are happening on the 3D head. Now remember that this is data that we loaded from the EEG Lab download. This is just sample data, but what we want to do is use our own data from Muse Lab and map it on 2D and 3D heads. So you can go back to the Muse Lab window and click down to recording. And what I'm going to do here is actually sit back and meditate and record my brainwaves. First, I want to set up the file name. You want to set it up something specific. I'm going to name it September 25th meditation. And what I'm going to do here, after that, I'm going to sit back and click record and sit back and meditate for a little bit while it records my brainwaves. When I feel I have enough data, I'm just going to click stop, and now it's recorded my brainwave data. Now the next step is to find the file of the recording. On my computer, it sent it to the desktop, and you can tell it's a Muse file because it's .muse, whatever you called it, .muse. And the next step is to find Muse Player. Now Muse Player should have been in the software development kit that you downloaded from the website. Open up Muse Player, and the terminal opens. And what you're going to see is a lot of sort of intimidating instructions on what to do with it, but it's actually pretty easy. What we're going to do is actually input the Muse file and output a MATLAB file. To input, it goes -F and then the file location, and then to output, you go -M and then whatever you want the MATLAB file to be called. Now open up a new window for the terminal, and one trick that I learned in doing this is that you can drag and drop your file into the terminal and it will give you the name of the location. I want you to copy that because that'll be important in the initial instructions for the Muse Player. So copy that, press enter, and then summon the Muse Player by typing in Muse -player, and then go copy and paste the location of your original file. Now to output, put -M and then whatever you want your MATLAB file to be called. So I'm going to call it -M MATLAB _ September 25th meditation.mat, and I want you to follow a similar format depending on what you want to do. And you can see the terminal, the Muse Player, crunching the numbers, converting everything to a MATLAB file, which is pretty awesome. Now, for some reason, on my computer, I have to go home, and I can find the MATLAB file within that location. So I'm going to drag and drop to the desktop and open it up for you in MATLAB. It's going to open up the file. You can just click finish. It's importing the data into MATLAB. And then once you open up, you can actually click on different things. If I click on elements, you see all the data. Everything that we saw in Muse Lab is now here in MATLAB. And I can click on beta relative, and you see all the raw numbers for the beta frequencies. If you go back to the Muse developers website, they explain what these numbers mean. And you can go down to the EEG descriptions, and it shows you what channels they actually are. Temporal parietal 9, frontal parietal 1, frontal parietal 2, and temporal parietal 10. Those are the names of the channels, and they correspond to where they are actually on your head. If you think of the Muse headset and where those little channels are, that's where they're picking up the information. And they're mostly on the front and on the sides of your head, so it actually makes sense that the channel names are called that if you look at the international agreement of what those channels are supposed to be called. Now what I'm doing here is I'm going back to the EEG research folder because what I want to do is I want to add our new data file to it, because if you recall in MATLAB all the paths need to be set in order to get the data that we want, right? So when I go to add the path to selective folders and subfolders, our new data file is in there to be analyzed. Now this is where I admit where my abilities are being a bit stretched, because I'm going to go in here and pull up the meditation file and go to elements, and I'm going to bring up alpha absolute. And I can tell you from my experience that if I was just trying to load this data into EEG Lab, it doesn't take. It doesn't take for whatever reason. I think the problem is the way that the EEG Lab reads the data is that instead of columns being channels, it reads as rows being channels. And what I found that if I transpose the data, basically turn it 90 degrees, it works. So I selected the the channel markers, right, the electrical numbers for the channel leads, and open a new window. And now I'm selecting them. And what I'm going to do is right click and go to transpose variable. And what that does is exactly what I just described, where instead of the columns being the channels, now the rows are the channels, and all the other data for the electrical frequencies are in there. Now these are absolute values as far as I understand. It's raw EEG data from my meditation session, and I'm going to save it as alpha absolute September 25th. I'm going to save that in the EEG research folder. Okay, so now you can see it loaded up in there. I'm going to clear the workspace. I'm going to get out of these command windows. Get back to the main command window. I'm going to enter in EEG Lab to bring up the graphical user interface. And I'm going to go to import data, and now I can import the MATLAB array. I'm going to go to browse. I'm going to go to the file that I created by taking the alpha absolute data and transposing it. It's right there, the alpha absolute September 25th.mat. I'm going to open that. I'm going to name it alpha absolute September 25. Click OK. Now the data is loaded in there. The next thing that you're going to need to do is add the channel locations. Now this took a bit of trial and error too, because recall, we only have 4 channel locations now. We can't use the standard data set that came with EEG Lab. Now what I found is that if you look at what the Muse developers website called the channels, you can use those channel names to get the data to automatically load in. So I'm going to click insert channel until I got 4 different channels. Now what I'll do is I'll go through the channels, and on each channel I'm going to enter in the code for where the channel should be. So on channel 1, you see I entered in TP9 for temporal parietal 9. Now I'm entering in FP1 for frontal parietal 1. Go to channel 3, enter in FP2. And then on channel 4 I'm going to enter TP10. Now the magic comes when you go down to this button called Look Up Locations and click OK. The program sees what you named the channel leads and then fills in the coordinates for you. And that was such a big revelation for me, actually figuring out how I could actually get all those coordinates for the channel leads. And the cool thing is that you can save the file as a .ced file. So just like with the 32 channel location file that we used from the example data set, now we can make our own data set for the Muse headset. Now I'm just going to call it the Muse headset locations and save that as a CED file that will be now available on my desktop for further use. Now at this point what I'm actually going to do is close out of EEG Lab at this time, because now that I have the .ced file, I can reopen EEG Lab and make things a lot easier on myself. So I'm going to close out. I'm going to reopen EEG Lab. I'm going to get to the import file section, import data. I'm going to go to import data and find my MATLAB file. Get back to the alpha absolute September 25th meditation recording. Click open, and then down there you can see channel location or file, and if you click browse, and then my .ced file is on my desktop at this point, so let me just find it here real quick. There it is, Muse headset location. So if I click open, now that loads in, click OK, and now both the EEG data and the channel locations are loaded in together. I'm just going to name this September 25th meditation. Click OK. And again, now both the raw EEG data and the channel locations are in there. Now if I try to plot that data as a component map, the program asks me to run an ICA. Now an ICA is an independent component analysis. And my understanding of it is that it takes absolute EEG data and turns it into relative frequencies. There's a whole mess of electrical activity that's going on in our heads at any given point, and any data, any measurements that we take from that is very hard to digest unless you break it into the relative frequencies. And I think that because we took the absolute alpha data, the program recognizes that and again wants us to run an ICA. My theory is I think that the Muse Lab runs ICA within itself so that you get those relative values. And I could be wrong about this, but again, I'm just learning along with the rest of you. So if I try to plot it, it asks for an ICA, so I'm going to run the ICA here. So I'll go to Tools, and then I'll go to Run ICA and click OK. And what it's doing now is taking the data from my meditation session and running the independent component analysis on it. You can see MATLAB working hard in the background. I like to let the program finish all the number crunching before I do anything further. Okay, looks like it's done now. So cool. If I go to Plot and then I go to Component Maps like before in 2D and click OK, it actually works now. You got your 2D maps, and you can see the data from my meditation session represented on these 2D maps. I think it's pretty straightforward. You can see that each channel location, depending on its location, has a higher frequency or have a higher power of the frequencies on the map, which is pretty straightforward. You would imagine that to be true. And again, to analyze the data further, I'd probably need a biostatistician or someone that's been in neuroscience PhD for years to make more sense of it. But if I want to plot it in 3D, I just open up the Plot 3D and go to the manual coreg here, bring up the spline file, click a warp montage, and as you can see, it's going to do the same thing we did with the standard set data, taking my Muse data and corresponding that to the 3D spline. And again, the MATLAB is working hard in the background to warp the Muse headset data onto the 3D model. So I'm going to let that finish, and then I'm going to click OK, and that should be loaded in. And when I click OK, there we get the 3D models of the Muse headset data by using EEG Lab within MATLAB. And there it is again. Depending on what channel you're looking at, you get the different intensities, and that would be to be expected if the device was actually working. I'm not sure exactly what the data is saying other than that, but again, just learn along with the rest of you. Thanks so much for listening. If you have a critique or advice of this, please email me at hello@techforpsych.com. I'd love the feedback. Thanks, guys. Bye.